Imagine looking into the night sky, a tiny point of light, so ordinary that you would never guess it was hiding one of the greatest mysteries in modern astronomy. Because according to everything scientists know, stars are supposed to die. Some quietly fade into darkness. Others explode in spectacular supernovas that briefly outshine entire galaxies. But one star refused. It should have disappeared years ago. Instead, it kept coming back again and again and again. Every time astronomers thought the story was over, the universe wrote another chapter. At first, they assumed it was an error. Maybe the telescopes were wrong. Maybe the data had been contaminated. Or perhaps another nearby object was confusing the measurements. But as more observatories looked, the impossible became impossible to ignore. This wasn't a mistake. Something in deep space was surviving when it had absolutely no right to survive. And if that sounds strange, the truth is even stranger. Because this wasn't just another unusual star. It behaved as if it simply refused to obey the laws that govern stellar life and death. For more than a century, astronomers have believed they understood how stars live. A star is born inside an enormous cloud of gas and dust. Gravity slowly pulls that material together until pressure becomes so intense that nuclear fusion begins. At that moment, a star is born. For millions, sometimes billions of years, that fusion acts like a delicate balance. Gravity pulls inward, fusion pushes outward. As long as those forces stay balanced, the star survives. But nothing lasts forever. Eventually, the star runs out of fuel. Fusion weakens, gravity wins, and death begins. This sequence has explained countless lives of stars across the universe. It is one of the strongest foundations of modern astrophysics, which is why what happened next left scientists speechless. When researchers studied this mysterious object, they expected to witness the final stages of its life. Everything suggested it had reached the point where collapse was inevitable. Its energy output had changed, its chemical fingerprints looked unusual, its behavior matched the final chapters of a dying star. Then, suddenly, instead of fading away, it brightened. Not just once, multiple times, almost as if something inside had restarted. That shouldn't happen. A dying star doesn't simply recover. It doesn't get a second chance. Yet telescope after telescope kept recording exactly that. Some researchers wondered whether they were looking at two different objects. Others believed an invisible companion star might be feeding it fresh material. A few even suggested that an entirely new type of stellar physics could be involved. But every new observation raised even more questions. Instead of solving the mystery, the evidence only made it deeper. Soon, major observatories around the world began pointing their instruments toward this strange object. Different wavelengths, different telescopes, different teams, yet they all kept reaching the same unsettling conclusion. Something about this star simply didn't fit. It was as if nature itself had hidden an exception inside one of its oldest rules. And that possibility terrified astronomers. Because if one star could ignore the textbook, how many others had they misunderstood? Could our understanding of stellar evolution be incomplete? Or were scientists witnessing an event so incredibly rare that humanity had never seen anything like it before? For years, those questions remained unanswered. Then, a new set of observations arrived, and hidden inside that data was a clue no one expected. A clue that would force scientists to completely rethink what they were actually looking at. And once they realized what it meant, the mystery became even bigger. That unexpected clue wasn't hidden inside the star itself. It was hidden inside its light. To most people, starlight looks simple, a tiny white dot shining in the darkness. But to astronomers, light is evidence. Every color, every wavelength carries information about what's happening billions of miles away. Using powerful instruments called spectroscopes, scientists can break starlight into tiny lines. Those lines reveal a star's temperature, its chemical composition, its speed, even whether it's moving toward us or away from us. In many ways, a spectrum is a star's fingerprint. So researchers expected this mysterious star to leave behind the fingerprint of an object approaching its final collapse. Instead, the fingerprint kept changing. 1 month, the star looked like it was dying. A few months later, it looked younger. Then, without warning, it changed again. It was as if someone kept rewriting its identity. That wasn't supposed to happen. Stars evolve over enormous stretches of time, thousands, millions, sometimes billions of years. Not months, not weeks, certainly not while scientists were actively watching. At first, researchers suspected unstable nuclear reactions deep inside the star. Perhaps a final burst of fusion was briefly pushing back against gravity. But the numbers refused to agree. The energy being released didn't match any known model. Then another surprise appeared. Historical observations were re-examined. Old photographs, archived telescope records, forgotten measurements collected decades earlier. Many of them had been sitting untouched for years. When those records were compared with modern observations, a shocking pattern emerged. This wasn't the first time the star had behaved this way. It had been repeating the same strange cycle for decades, possibly even longer. Some brightening events had occurred before modern digital astronomy even existed. The mystery wasn't new. Humanity had simply failed to notice it. That realization changed everything. Instead of investigating a single strange event, scientists were now looking at a long-running cosmic mystery, one that had quietly unfolded while generations of astronomers watched the sky. The obvious question became, what could keep bringing the star back? One theory pointed toward a hidden companion. Perhaps another nearby star was slowly transferring gas onto its surface. As enough material accumulated, a violent burst of energy could erupt, making the star appear alive again. It sounded reasonable until better observations arrived. No companion could fully explain what telescopes were seeing. Another idea suggested something even stranger. What if the object wasn't behaving like a normal star at all? What if it belonged to an extremely rare class of stellar remnants that scientists barely understood? If that were true, then every textbook explanation would need serious revision. The debate spread quickly. Some astronomers argued they were witnessing the aftermath of repeated partial explosions. Others believed the star was trapped in a cycle unlike anything ever confirmed before. No one could prove either idea, and every new observation seemed to support one theory while contradicting another. The deeper scientists looked, the more confusing the evidence became. Then, a space telescope captured something no one expected, a tiny detail almost invisible at first. But once researchers realized what they were seeing, the investigation took a completely different direction. Because this wasn't just a star refusing to die anymore. It might actually be surviving for a reason. And discovering that reason would lead scientists toward one of the strangest ideas in modern astrophysics. That tiny detail changed the entire investigation. The space telescope had captured something almost invisible. Not a massive explosion, not an unusual flash, but a subtle pattern hidden inside the star's brightness. At first, it looked like random noise, the kind of tiny fluctuations astronomers often ignore. But after months of careful analysis, the pattern appeared again and again and again. It wasn't random, it was repeating. That was the moment scientists realized they weren't just watching a dying star, they were watching a cycle. The star wasn't returning to life by accident. Something was triggering it. But what? Researchers from different observatories began combining data from ground-based telescopes and space missions. Visible light, infrared, ultraviolet, even X-ray observations. Each wavelength revealed a different piece of the puzzle. And when those pieces were finally placed together, a surprising picture emerged. The star wasn't experiencing a complete death. Instead, it appeared to be going through repeated partial eruptions. Imagine a volcano that never completely explodes. Pressure builds deep inside, it erupts, then calms down, only to begin building pressure all over again. Some astronomers believed this star was doing something similar, except instead of lava, it was releasing enormous amounts of energy into space. That idea seemed promising until another problem appeared. The eruptions weren't strong enough. According to every accepted model, each outburst should have stripped away enough material to end the cycle forever. But somehow, the star kept holding itself together. It was losing mass, yet it refused to collapse. It was weakening, yet it refused to disappear. It was surviving against every prediction. The mystery became so unusual that researchers started comparing it with one of the rarest objects in the universe, a white dwarf. A white dwarf is the dense core left behind after a sun-like star dies. It's incredibly small, incredibly hot, and unbelievably dense. A single teaspoon of its material would weigh tons on Earth. Normally, a white dwarf slowly cools over billions of years. Its story is supposed to be over. But what if this wasn't a normal white dwarf? What if it was still stealing material from a nearby companion? If enough hydrogen collected on its surface, it could ignite in a violent thermonuclear burst. The explosion would make the star appear dramatically brighter without destroying it completely. Then the entire process could begin again. For the first time, scientists had a theory that explained why the star kept coming back. But even this explanation wasn't perfect, because several observations still refused to fit. The timing wasn't consistent, the brightness wasn't always the same, and some eruptions released more energy than the theory allowed. It was as if the universe accepted the rules, only to break them at the last second. Then came the biggest surprise of all. A newly analyzed burst showed that the star's outer layers had survived far better than expected. That shouldn't have been possible. Every calculation predicted far more damage, yet somehow the star endured once again. The discovery forced researchers to ask an uncomfortable question. What if they weren't looking at a broken star, but at a completely new category of stellar behavior? If that were true, then this object wasn't simply refusing to die. It was teaching humanity that stars may have far more than one ending. And in the final stage of this investigation, scientists would confront the most unsettling possibility yet. That the universe still holds secrets about stellar death that no textbook has fully explained. For years, scientists searched for one simple answer. Why wouldn't this star die? But the deeper they looked, the more they realized they had been asking the wrong question. The real mystery wasn't why the star survived, it was what kind of death it was actually experiencing. Today, many astronomers believe the object is not truly immortal. Instead, it appears to be trapped in a rare cosmic cycle. The leading explanation is that the star is part of a binary system. Hidden nearby, almost impossible to detect directly, is a companion star. Gravity slowly pulls hydrogen-rich gas away from that companion. The stolen material doesn't disappear. It falls onto the surface of the dense stellar remnant. Month after month, year after year, the pressure grows, the temperature rises, until finally the surface erupts in a powerful thermonuclear explosion. For a brief moment, the star suddenly becomes dramatically brighter. From Earth, it looks as though the dying star has somehow come back to life. But the explosion isn't strong enough to destroy its core. Instead, the surviving remnant remains intact. Then the process begins again. The star steals more material. Pressure builds, another eruption follows, and once again, the universe creates the illusion of resurrection. This phenomenon is known as a recurrent nova. It is one of the rarest behaviors ever observed among stars. Only a handful of confirmed systems in our galaxy behave this way, and each one gives scientists a priceless opportunity to study stellar evolution in real time. But the mystery doesn't end there, because every eruption changes the star ever so slightly. Some researchers believe that if enough material continues to accumulate, the white dwarf could eventually reach a critical limit, a point known as the Chandrasekhar limit. If that happens, everything changes. Instead of another temporary eruption, the entire star could trigger a catastrophic Type 1a supernova, an explosion so powerful it could briefly outshine billions of stars. The object that once seemed impossible to kill would finally disappear forever. Ironically, its repeated survival may actually be preparing it for one of the most violent deaths in the universe. And scientists still don't know exactly when that final moment could arrive. Tomorrow, 1,000 years from now, or perhaps hundreds of thousands of years in the future. No one can say. That's what makes this mystery so fascinating. Every observation, every new burst of light, every tiny fluctuation recorded by telescopes could reveal another clue. Not just about this extraordinary object, but about how stars live, how they die, and how much humanity still has left to learn.